Hi everyone, in this video I'm going to show you how to modify data frames in R using the TIDYVERSE library. The TIDYVERSE library has a lot of stuff that we can work with, and this is just one part of it. In another video I'll also show you how to create beautiful graphs and charts using the TIDYVERSE, but in this video it's all going to be about data frames. So let's get started. Some of the things that we're going to look at in this video is how to create new data, drop missing data, filter data, how to calculate the mean or max or summarize data, and also group it. So these are the most popular functions that you would apply to a data frame, and we're going to go through all of them one by one. Okay, so obviously to work with the TIDYVERSE library, we need to install the TIDYVERSE library. I already have it installed, but if you need to do that, all you need to type in your console is install.packages, and then in that, in those brackets there, type out the word TIDYVERSE and then click enter. I'm not going to do this because I've already installed it, but that's how you would go ahead and install TIDYVERSE into your R environment. The next thing we need to do is import the TIDYVERSE library. So we're going to use the library function and then type in TIDYVERSE and click enter. And you'll see that it installs all of the core TIDYVERSE libraries. The one that we're going to use today is Tibble and dplyr. Both of these are meant for modifying data frames, so that's what we're going to use. Okay, so the next thing we need is some data. I want to make sure that you and I are working with the same data set, so we're going to use one of the built-in data sets in R called iris. So let's go ahead and import the iris library. We're using the data function that allows you to import built-in data frames in R, and the name of the data frame is iris. So go ahead and type that out and click enter. And you'll see in your environment, you have a new value called iris. And if we type iris into the console, you'll see a snapshot of what that data looks like. Scrolling through the console is not ideal. So let's type in view with a capital V and then iris. And if you're using RStudio like me, it'll open up a brand new tab right next to your code window, and it'll allow you to take a look at the data frame. So the data frame is essentially a data set on flower measurements. So iris is a type of flower, and you can see that you get the length of the flower, of the sepal, I'm not sure what that is, and the petal. And then you also get the species of the iris. So it's a really interesting data set, and everything that we're going to do is on this data set. Okay, so the first thing I want to do is turn the iris data frame into a Tibble. A Tibble is a really useful way to look at data because it allows you to take a look at a snapshot of the data set instead of having to scroll through your console every single time. So let's create a new variable. We'll call it df for data frame. And we're going to use a function called asTibble. And then in that function, we're going to put in the name of the data frame that we want to modify. So for us, that's iris. Click enter. And now we can take a look at the data frame. And you can see it looks different now. You only get a snapshot. You get the number of rows and the number of columns, and you get the first 10 rows in the console. It's very different from this one where you get a lot more rows, but you have to scroll through them. So you get the first 10 rows, and you can see how many more rows are left. So this is what we're going to modify, this Tibble. What we're going to do now is create a new column in our iris data set. So let me show you how to do that. We are going to provide the name of the variable we want to modify. So for us, that's our data frame. We're going to use something called a TIDYVERSE pipe, which looks like this. And we're going to create a new column using the mutate function. So it looks like that. And this is how you add operations to your data frame. If you want to filter it, you add another pipe, and then you add a filter function. Right now, we're only going to focus on mutate because I want to add a new column. And I'm going to create a new column called sample length, and that's going to be equal to my petal length multiplied by 2. So if we highlight that and click run, you'll see that it's been created. So there wasn't enough room in our main window to plot the data, but you can see that a new column has been created. It's called sample length, and it's the petal length times 2. Let's go back to our code here. So we use the mutate function, we specified the name of our new column, and we told what the new column should be equal to. And it doesn't have to be a modification of an existing column. If I want my new column to just be 2, I can make it just equal 2. So let's create a variable called df2 and then make it equal the main data frame with our new column. And let's view this new data frame. And you can see our sample length is just 2 because in my code, I made sample length equal 2. If we go back to our original calculation, petal length times 2, we can click enter and we can take a look at our sample length, and you can see that it's the petal length here multiplied by 2. So that's a really great way of creating new columns, and you can see it's just one line of code. Okay, so the next thing I want to show you how to do is drop missing data. Iris does not actually have any missing data, so our data frame won't actually change, but I think it's important to know. So we are going to copy this code chunk, add it here. And if you want to build on our data frame, we're going to add another pipe. And to drop missing data, the function is called drop NA. So let's talk about this function for a second. I'm going to run it. Run. Now, again, our data frame doesn't have any missing data, but if there was a missing value under the sepal length, so when I say missing value, I mean if this, instead of a 5, if it had NA for not available, this entire row would be removed. It doesn't have to be missing across all columns. All you need is one missing value in any column, and that entire row will be removed. So keep that in mind. Drop NA will remove any rows with missing data in your data set. It quickly just gives you a clean, complete data set to work with. The next thing I want to show you is how to select columns. So let's highlight this again and copy it down here. So right now we have 6 columns, and I don't need all 6 columns. I only want a few. Let's pretend that I was building a linear regression model and I was interested in modeling something about the petals. Maybe I was not interested in the sepal length or the sepal width. We can remove them very easily. So we're going to add another tidyverse pipe. And we're going to use the select function. So the select function looks like this. And you can use select to remove or keep columns. I want to remove columns, so I'm going to type out the name of the column that I want to remove. So sepal length. Sepal length. And I'm going to put a negative sign in front of it, or a minus sign, whichever one you want to, whatever you call it. And that will remove the sepal length column from my data set. So let's highlight this and click run. We'll go back to the df2 data frame, and you'll see that sepal length is gone. It no longer exists in the data frame. You can also do the opposite. So instead of having to specify the columns that you want to remove, you specify the columns that you want to keep. So let's remove sepal length and go back to our data frame. Oops. Let's remove this entire pipe actually. Click enter. So you can see our data frame is back to the original length. If I only want to keep the petal length and the petal width, I can do that by specifying that in the select function. So I can do select petal length and petal width. So what I'm saying is I want you to remove all the columns except for petal length and petal width. Let's highlight that, click run, and then we can go back to our data frame. And you can see we only have 2 columns now. So this is a way to filter out columns that you want or you don't want. You can also specify the index of the column if you don't want to type out the whole name or you want to group together a bunch of columns that you want to keep. So let me show you what I mean. If I only want to keep the first 3 columns, I don't have to type out the names of the actual columns. I can just specify the column index, which is 1 through 3, so 1:3, and this will only keep the first 3 columns. So let's run that and take a look. We have the first 3 columns. If I want to keep columns 1 through 3 and then in column 5, all I have to do is specify 1:3 and then add a 5 with a comma, separated by a comma. Click run, and you can see that it only kept columns 1, 2, 3, and then column 5. And keep in mind that R and Python use column indexes differently. In R, the first column is always column 1. So just be wary of that. Okay, so I think I'm pretty happy with the column selection that I have so far. So I have 3 columns here. So I'm going to copy this entire chunk of code and then move it down into our next section, which is the filter section. So sometimes you want to remove certain data sets or you want to filter for a certain variable. Doing that in the Tibble library is pretty straightforward. So let's come up with a filter. Let's say that I only want to keep rows where the sepal length is greater than 4.5. So you can see here, I have some values. Row 14 has a sepal length of 4.3. We have a couple values where we have 4.4. For whatever reason, I don't want those values. So we can add a filter to our data frame so that I'm only keeping values where the sepal length is greater than 4.5. So to apply this filter, the function that we need is filter. Let's add a tidyverse pipe. What we can do is type out the word filter. In those brackets, we're going to specify what we want to filter. So I want to filter out sepal length values that are less than 4.5. In other words, I want to keep values that are greater than 4.5. So we're going to do sepal length, and make sure I spelled that right. Okay, they have to be greater than 4.5 for me to keep them. So let's highlight our data, our code, run, and take a look at our new data frame. And now if you scroll through the sepal length column, you'll see that we don't have any values that are less than 4.5. Let's add a second filter. Let's say I only want to keep values where the petal length is less than 5. So we can add petal.length less than 5, and both of these have to be separated by a comma, and then run our code. And now you'll see that we only have values that are less than 5. And we can confirm that by just clicking the little arrow here. And you can see that the maximum is 4.9, so that's good. The next thing I want to show you is how to group variables together. And this is helpful because if you want to explore a certain variable, it makes sure that they're all arranged in the same format or the same order. I personally use group by for a very specific function. I like to group by variables and then summarize for that variable. Don't worry if this sounds confusing. I'm going to show you exactly what I mean. So I have a lot of data here, but I might not be interested in looking at it on a row by row basis. So what I want to calculate is what is the maximum petal length for every species of iris. So we have a couple species here. We can actually clarify how many species we have by using the unique function. So unique df2, and then we can check the unique species values. We have 3 different species of iris. What is the average petal length for each species of iris? So what I'm going to do is group by the species. All of the setosa will be grouped together, all of the versicolor will be grouped together, so on and so forth. And then from each of those groups, we're going to calculate the average. And for this grouping function, I'm actually going to take the entire data set, not just our modified one. I'm going to create a new data set called df3, and we're going to modify the original df data frame. We're going to group by the species. So this will allow all of these species to be grouped together. Let's confirm that. View df3. So you'll see they're all grouped together now, which is what I want. And now I want to summarize. So I'm going to add another tidyverse pipe, and I want all of the species grouped together, and I want to calculate the mean petal length. So summarize. When we calculate the mean petal length, we need to create a new variable. So we're going to do mean petal length, and it's going to equal mean, we're using the mean function, petal.length. So we're summarizing all of our data. We're going to group it by species, and we're calculating a new variable called mean petal length. So let's run this. And now if we take a look at the df3 variable, it's been modified. So now we only have 3 rows, 1 for each group of species, and we have the average petal length for each species. We could also do the max. So if we want to do max petal length, max, and then max, we can run that, and it'll switch to max petal length. And the summarize function is a very popular function for people that use Tidyverse. It allows you to quickly come up with basic statistics for your data with one line of code. So knowing how to summarize data is really important. So that brings me to the end of this video. These are all the most popular functions used to modify data frames in R. And I'm going to go through all of the Tidyverse libraries, including ggplot, lubridate, and more. So if you're interested in that, let me know. And I hope you enjoyed this video, and good luck. Thanks for watching.